Okay, we're going to do the S10 Derivatives Study Guide. Woo! Okay, so let's get started here. Um, I'm just going to walk you through the steps. Okay. All right, so first of all, um, the way the spacing of this was very weird. Um, I don't know if that's better or not, but okay. So this equation right here is supposed to be um, negative 2t squared plus 16t minus 24. So um, hopefully I'll fix that before the next people watch this. Okay, so find the times when p is at rest. Okay, so this is velocity. So in order to figure out when it's at rest, the velocity is going to be 0. So that's what I've written here. So in order to figure out when it's 0, um, I'm going to make my equation equal to 0. Okay, and then I factored out the 2. And then I said, okay, this is factorable. What two things multiply to give me 12 and add up to give me negative 8? And that would be negative 2 and negative 6. So we know that it's at rest when t equals 2 and when t equals 6. Okay? All right, next question. Find the magnitude of the particle's acceleration at 6. Okay, so I need to figure out the derivative. The derivative of this is negative 4t plus 16. This 2 comes to the front, gets multiplied, becomes 4. This 16t becomes 16. Okay, and we want to do this when the acceleration is at 6. So I'm going to plug in 6. This is my acceleration. Right, so I plug in 6 in here, and then negative 4 times 6 plus 16 gives me negative 24, and acceleration is negative 8. So the magnitude is 8 meters per second squared. Okay, so question C. Find the greatest speed of p between 0 and 6. So the greatest speed is the greatest speed is at time 0. Because if I look at this function, if I plug in 0 in for here, I get negative 24. And so a velocity of negative 24, it doesn't matter if it's positive or negative. We want to find the absolute value of the velocity is what we're looking for. So the absolute value of the speed, whichever, and negative 24 is going to have a greater speed than any of the positive values we've got. Okay, D. The particle starts at the origin. So find an expression that represents the displacement of p and time in seconds. Okay, so we have to take the antiderivative, and when t is 0, the location is 0. So if I take the antiderivative of this, this power becomes a 3, and then we have 1/3 times this negative 2. This power here, with the 16t, that's going to become, the power of that's going to be 2, and we're going to have 8t. And then this negative 24 is going to be negative 24t, and then we put plus 6. Okay, this looks like this is plus 16t. Okay, that looks like an H to me. That was bothering me. Okay, so so now I've taken the antiderivative. I can figure out c by plugging in for 0, I'm going to plug in 0 there, there, and there. And for my location, I'm going to replace S with that 0. Okay, and then we get C is 0. And so there is my function that does displacement. Okay. And I use the variable S. A lot of times in math books, don't use the letter D, because D and the lowercase d for derivative can get confusing. So I don't know what letter to use, but I use the letter S. A lot of math books use that, and I hate it, but oh well. Okay, question E. Find the total distance traveled by P between 0 and 4. Okay, so we want to find the total distance. So if I put this into my graph, it's going to look like this. So, my function is this: negative 2t squared plus 16t minus 24. So, I'm just going to talk this through. Okay. So to graph this, here's my window that I set up. I made the x minimum 0, the x max 6, because they, well, I guess I could have done it at 4, because they want it between intervals of 1 and 4, right? Anyways, we're looking at it between 1, x equals 1, and x equals 4. Okay, and then I set the y minimum to negative 30 and the y maximum to 20. That gave me a nice window to see the picture. Okay, so when you type in the graph, here, this is what I typed into the calculator. Notice that part of the graph is down below, and part of the graph is up above. Okay, so these two portions of the graph represent the distance traveled. Now, this is the distance in one direction, this is the distance in another direction, and so we have to add them together to figure out the total distance traveled. So if you just typed in the integral, so by the way, the calculator will do the integral for you. If you hit second and trace and go over to 7, that will give you the integral. But that's going to give you the wrong answer, because this part's negative and this part's positive, and it's going to actually not add them together. It's going to subtract them. So what you have to do is you have to do the antiderivative from 0 to 2 first, which is what I did here. And then you do the antiderivative from 2 to 4 next. And that's what I did there. Okay. So I'm going to get on my calculator just to show you. To my backpack. Okay. Because you need to see what I'm doing here. Okay. So y equals, let's type this in, negative 2 x squared plus 16, oops, what the heck, 16x, let's try it again, negative 2x squared plus 16x minus 24. Okay, so, and I'm changing the window, 0 and 6 and negative 30 and 20. Graph. And it looks like the picture that I just showed you. Okay, so I need to, I want to graph this blue portion. So I have to hit second trace. I'm going to go down to 7 for the antiderivative. Okay, I'm going to hit enter, and then it says lower limit, and I'm going to type in 0, and then I hit enter. And now it says upper limit, and I'm going to type in 2, and I'm going to hit enter. And now it's shaded that in, and it's told me that that area is negative 21.33. So I'm going to put a negative there, and so I know that area is 21.3. And now I need to figure out the other area. So I'm going to do second trace, go down to 7, the integral one, enter. And now my lower limit is going to be 2. I hit 2 and enter. Now it says upper limit. I'm going to put in 4 and enter. And now I know this area is 10.66. And then I add those two together, and I get the area traveled. Both of those areas together is 32 meters. Okay? Let's do the next one. Okay, the next one is just a product rule question. Okay, so I let u equal to 2x, and I let v equal to 4 minus e to the x. The derivative of 2x is 2. The derivative of 4 minus e to the x is negative e to the x. So once I do product rule, I end up with negative 2 e to the x, and then this. So I did distributive property with the 4, and then I get plus 8 and minus 2 e to the x. Hit pause if you need to copy this down or think about it. Okay, now the next one says, okay, we're going to find the second derivative. So this blue one here, I'm going to do product rule for, but the derivative of 8, it's just going to go away. The derivative of negative 2e to the x is going to be negative 2e to the x. So for this part, negative 2x e to the x, I'm going to let u, I'm going to use product rule again. Okay, and that's for this part right here. And so u is equal to the negative 2x, and v is equal to e to the x. So the derivative of negative 2x is negative 2. The derivative of e to the x is e to the x. And so here I've written this out with product rule. Hit pause if you need to think about it, or stop for a second. Okay, and now I see I've got e to the x times negative 2 is going to give me that. Wait. Okay, negative 2 e to the x. This right here is going to give me negative 2 e to the x. That hasn't changed. And then I've got this guy right here, e times negative 2, e to the x times negative 2. And here I have negative 2 e to the x. These are the same, right? So adding them together, I'm going to get negative 4 e to the x. Okay, and then this is a fine answer. There's nothing wrong with that. But if I wanted to factor out e to the x and factor out negative 2, it could look like this also. This was the answer in the book. I think both of these answers are perfectly fine. Okay, question B says the curve has a point of inflection at a comma b. Find the value of a. So when you have a point of inflection, you know that the second derivative is 0. Okay, and we learned that earlier in this unit. The second derivative is equal to 0. okay, at the inflection point. Okay, so we know that e to the x, this is never going to be 0. That's never going to be 0. So now I have to look at this factor, x plus 2. So when x plus 2 is going to be 0, we know that x is going to be negative 2. So this inflection point, the a value of the inflection point is negative 2. Okay, next question. Okay. A particle moves such that the velocity in meters per second is written like this: t times sine t squared. Okay, find an expression of the acceleration for the particle. So to find the expression of the acceleration, I've got to take the derivative. Okay, so using the product rule, I'm going to say that u is equal to t, and v is going to equal to sine t squared. Okay, the derivative of sine t squared is 2t cosine t squared. The derivative of t is just going to give me 1. So now I'm going to replace all this in here. So I've got u times v prime plus v times u prime. Okay, this is a 1. Okay, so now I've got t times 2t, that's going to be give me 2t squared cosine t squared plus sine t squared. Okay. Question B. Hence or otherwise, find its greatest acceleration between 0 and 8. So I need to graph this to see what this thing's going to look like. So the first thing I'm going to do is I hit y equals, and I type in 2x squared cosine x squared. Here, let's just do this right now. Okay, so 2x squared cosine x squared close parentheses plus sine x squared close parentheses. Okay, I believe I've typed that in correctly. I'm going to hit second trace and figure out the maximum. Before I do that, I need to change my window so I can see this. So I'm going to hit window. I'm going to change x min to 0, x max to 8, and I already played around with this. The y min is going to be negative 200. The y max is going to be 200. And now I'm going to hit graph. And you see that the graph is going to look like this. Okay. So we've practiced this many times. If you do second trace to find the maximum, that's going to give us this point here. And so you do your left bound, right bound, guess. You hit enter 3 times. So the left bound has to be somewhere over here. The right bound has to be somewhere over here. And then I hit enter when I see guess, and then I get my maximum. And you should get something like 126 meters per second. Okay. Okay, question C. The particle starts at the origin. Find an expression for the displacement of the particle. So once again, I need to do the antiderivative. So the antiderivative of this is negative 1/2 cosine t squared plus c. I know we haven't talked about antiderivatives yet, so for right now, just trust me that that's the antiderivative, and we'll be doing that when I teach you chapter S11. So, but for right now, just accept that that's the antiderivative. So our starting position is 0 at time 0. So I'm going to replace the s with 0, and I'm going to replace the t with 0. Okay, and then if I get my sorry, I'm back. If I get my unit circle, and if I have cosine 0, for my unit circle, cosine 0 is 1. So I'm going to replace cosine 0 with 1. So then I end up with negative 1/2 plus c. So c is going to be equal to 1/2. And so here is my equation, and now I've written c with the 1/2. Okay. So question D, since hence or otherwise show that the particle never has a negative displacement. So basically, we know that the value of cosine is never going to be less than 1. If we look at this value, the blue value here is cosine, right? And notice it's never going to be, here it's at negative 1, here it's at 1, but it's never going to be greater than 1 or anything like that. So because it's never going to be, it's always going to be less than 1, and negative 1/2 times a number less than 1 plus a half is always going to be a positive number. Okay. Let's do question 4, and then we'll do the rest of it on another video. Okay. The wind chill index is in centigrades. I'm sorry, Celsius, and is felt when taking into account the effects of wind. So Frida has arrived to the top of the hill, and the wind chill factor, she's got this equation. Okay, so find an expression for the derivative of this. Okay, so here is my equation. W equals 19.34 minus 7.405 v to the power of 0.16. So to take the derivative, this here is going to just go away, right? The 19.34, that goes away. And then when you take the derivative, this power gets multiplied by the 7.405. Right? This power of 0.16 gets multiplied by the negative 7.405, and then this power decreases by 1. Okay, and so there is my my derivative. Okay, so they're asking for part B, find the rate of change of W at this time. So they're asking me to find W dt, the change of W with respect to time. And so I'm going to have to use the chain rule to help me think about how this works. So using the chain rule, dW dt is going to be equal to dW dV times dV dt. Okay, so dW dV, we just found to be this yellow answer. This is the answer from part A, right? Okay. And dV dt, they've already told you right here that when she starts at the top of the hill, when the wind is 10 kilometers per hour, the rate is increasing at 5 kilometers per hour per minute. So dV dt is 5 kilometers per hour per minute, and this is happening when the wind speed is 10. Okay, so I'm going to replace the V right here with 10. Okay, so now I can put this into my calculator, and I end up with the change of W with respect to time is equal to this. I'm going to hit stop, and you can learn the rest of this in part 2 of this video.